When agents use tools, the tool boundary becomes a security boundary. In this module, we'll make that boundary explicit, define allowed actions, validate every argument, enforce least privilege, and filter outputs before anything returns to the model. So far, we've covered why agents create unique risks, how tools turn reasoning into real-world action, and how least privilege limits what agents can reach. Now we'll tighten each tool boundary with narrower schemas, stronger argument validation, and output filtering before we move into sandboxing. A tool schema is the contract between an agent's reasoning and the systems it can touch. It defines which requests are allowed, which parameters are valid, and what kind of response may come back. That matters because ambiguity becomes risk. If an action name is vague, an input is loosely typed, or outputs are unrestricted, the model may make unsafe assumptions, and attackers may steer those gaps. Strong schemas narrow choices before execution, much like secure API design. Prompting helps, but validation is the control point. Each tool should behave like a permission boundary. A narrow tool, such as get invoice status, can only perform the business action it was designed for. Even if an attacker injects instructions, the blast radius stays small. A broad tool, such as run SQL query or execute shell, gives the agent open-ended power. That creates many failure modes: data exposure, modification, discovery, or harmful commands. Prefer interfaces that encode intent directly, such as lookup order status or resize image. They are easier to validate, monitor, test, and audit because misuse has fewer paths. Another useful frame is to treat a tool like a service counter, not a master key. The agent should be able to request an approved business outcome, such as refund an eligible order, rather than run arbitrary SQL or touch payment tables. That keeps database names, file paths, commands, and internal structures out of reach. It also narrows inputs to what the workflow truly needs: order ID, amount, reason, and maybe a notification choice. Most importantly, the tool itself must enforce eligibility and assumptions, so safety does not depend only on a prompt behaving well. Security starts before the tool runs. If the schema accepts vague inputs, the agent can accidentally ask for the wrong thing. Design parameters that narrow the path. Use names that carry intent, like customer ID rather than ID. Prefer typed fields, enums, and known identifiers over free-form text. Split different actions into different tools, so delete, update, and email are not hidden behind one generic operation parameter. Make the safe choice the default, and require confirmation for sensitive actions. The best schema makes risky requests awkward to express. Input validation is the gate between an agent's request and any real-world action. Even if the model has safety instructions, treat every tool argument as untrusted. First, check the schema. Required fields, types, sizes, and formats. Then check business rules, such as whether an amount is allowed, a date makes sense, or an action is permitted for that user. If anything fails, reject it predictably and return a minimal, safe error. Only validated, authorized inputs should reach tool execution. Basic validation is the first gate every request should pass through. Enforce exact types. An ID is an identifier, price is a number, items is an array, and flags are booleans. Require only the fields the action truly needs, and reject unexpected fields unless the API explicitly supports them. Add maximum lengths so huge strings cannot become prompt stuffing or denial of service payloads. Set numeric and date bounds for quantities, pagination, and ranges. These simple schema rules turn messy input into predictable data and block many failures before business logic runs. From there, validation should turn vague user input into narrow, predictable values before any tool or backend sees it. Regex patterns help with structured IDs, like orders or tickets, because they reject malformed strings early. Enums are better for intents. Instead of interpreting help with my order, force one approved value, such as billing, shipping, or technical support. For resources, avoid raw paths, URLs, database names, and account numbers. Use opaque identifiers, then verify the identifier belongs to the current user, tenant, or authorized context. Format validation is necessary, but ownership validation is what makes it safe. A request can be perfectly shaped and still be dangerous. Imagine a return or refund tool receives a valid order ID, user ID, and amount. Schema validation only says the fields look right. Business rule validation asks the harder questions. Does this user own that order? Is the order eligible for return? Is the amount within policy, and does it require approval? Is the workflow state correct, such as delivered before return opened? These checks prevent confused deputy failures, where the agent uses its access to affect resources the user cannot control. When validation fails, the tool should follow a fixed decision path, not improvise. If the request is dangerous or violates policy, reject it completely and execute nothing. If the problem is only a minor format issue, allow repair only when the correction is safe, deterministic, and low risk. If the intent is ambiguous, the action is high impact, or the pattern looks suspicious, escalate to a human reviewer. Log every failure as well. Those logs help detect abuse, tune schemas, and make future validation rules stronger. Tool responses deserve the same scrutiny as tool inputs. A backend may return everything it knows: customer details, payment tokens, logs, internal notes, and order data. The agent usually needs only a small slice of that. An output filter acts as a security boundary by removing sensitive fields, redacting secrets, summarizing noisy results, or transforming records into a task-specific answer. Instead of handing the model a full order record, return something like status, shipped, estimated delivery, Friday, next action, notify user. Less data means less leakage, less distraction, and safer execution. Output safety is not one technique. It depends on the job the user needs done. If exact values are unnecessary, redact them. If the source material is risky or too detailed, summarize the conclusion instead of returning raw text. If the model only needs to classify or decide, transform records into safer labels, bans, or policy outcomes. If the question is about patterns, aggregate across many records so individuals disappear. The trade-off is always the same: reduce exposure as much as possible while keeping enough signal for the output to remain useful. Before any tool is exposed to an agent, treat the schema as a security boundary. First, confirm that the interface represents the narrowest useful business action, not a general-purpose capability. Then lock down every argument with type, length, pattern, enum, identifier, and business rule validation. Next, review outputs. Return only what the agent needs, and strip secrets, unrelated records, excessive detail, or embedded instructions. Finally, add operational controls: logging, alerts for validation failures, usage anomalies, and unexpected output volume. If any area is weak, block release. The pattern is simple. Make unsafe requests hard or impossible. Use narrow tool schemas that expose only business actions. Validate every argument against syntax, ownership, authorization, and policy. Then filter outputs so sensitive data does not enter model context. Next, we add sandboxing and execution isolation, because safe tool design should be the default path.